Welcome, data engineers and architects. Today, we are diving into a game-changing public preview feature, Snowflake Cortex Agents. We will explore how to build autonomous, multi-turn AI workflows that can reason, use tools, and securely interact with your enterprise data. Let's get started. Let's define Cortex Agents. In traditional application development, if a user asks a complex question, developers must write rigid, hard-coded logic to fetch data, format it, and return a response. Cortex agents fundamentally shift this paradigm. An agent is an autonomous, LLM-powered orchestrator. You provide it with a high-level goal, behavioral instructions, and a toolbox. When a user submits a prompt, the agent autonomously decides how to answer it. Why is this critical? Because enterprise users rarely ask simple questions. They might ask for structured revenue metrics in one breath and unstructured contract details in the next. Cortex agents seamlessly bridge this gap, dynamically selecting the right tool for the job while ensuring all data processing stays securely within Snowflake's governance perimeter. Look at this high-level architecture. The user prompt enters the Cortex agent. Rather than following a single predefined path, the agent acts as an intelligent router. It analyzes the intent and branches out, grabbing relational data via SQL, fetching text from documents, or even triggering an external API. It then synthesizes these discrete data points into a unified agent response, delivering a seamless experience to the end user. To master Cortex agents, you must understand their cognitive workflow. When a prompt arrives, the agent doesn't just blindly guess an answer, it enters a planning phase. It breaks complex questions down into smaller subtasks and disambiguates vague terms. Next is tool routing. The agent reviews its available tools and maps each subtask to the correct tool. In the execution phase, it actively uses these tools to retrieve enterprise data. But the most powerful step is reflection. After executing a tool, the agent looks at the returned data and asks itself, does this actually answer the user's question? If it hit an error or retrieved the wrong data, it can self-correct, select a different tool, and try again. This iterative reasoning loop is what makes the agent autonomous. This state diagram illustrates the agent's internal reasoning loop. Starting from planning, it moves to tool selection and execution. Notice the critical loop at the reflection node. If the data is insufficient or an error occurs, the agent routes backward, choosing to retry or pick a different tool. Only when the reflection phase confirms the data is sufficient does the agent break out of the loop and deliver the final response. What tools are in the agent's toolbox? Snowflake provides two incredibly powerful native tools out of the box. First is Cortex Analyst. Analyst is an agentic text-to-SQL engine. By providing it with a semantic view which maps business terms to your database schema, the agent can autonomously write and execute SQL to answer quantitative questions. Second is Cortex Search. This is a fully managed retrieval engine that uses vector embeddings to search through unstructured text, like PDFs or transcripts. The magic happens when you give the agent access to both. The agent can seamlessly handle a user asking for Q3 revenue figures, which routes to Analyst, and simultaneously asking for qualitative summaries from the Q3 board meeting notes, which routes to Search. The integration is flawless and requires no manual data movement. This diagram shows how the agent planner interacts with the tool registry. When the planner identifies a need for structured metrics, it invokes the Cortex Analyst tool, which communicates directly with your semantic views and SQL tables. When it identifies a need for qualitative text, it invokes the Cortex Search tool, pinging your vector search index. The agent manages this routing dynamically. Reading data is great, but true autonomous workflows require taking action. Cortex agents allow you to register custom tools. You define a custom tool using a JSON schema that outlines the tool's name, its purpose, and the exact input parameters it requires. The LLM reads this description to understand when and how to use it. You can back these tools natively using Snowflake user-defined functions or stored procedures. For example, an agent could run a Python UDF to trigger a machine learning model or update a database record. Furthermore, Snowflake supports client-side execution. This means the agent can format the exact JSON payload needed to trigger a tool, pause its execution, and hand the payload back to your external application to execute an action in a third-party CRM or ERP system. Let's trace a custom tool invocation. The agent tells the LLM planner it needs to calculate a shipping cost. The LLM planner reads the tool descriptions and matches the intent to your custom get shipping tool. It formats the required JSON payload-like location Newark and securely executes the custom UDF running on your Snowflake warehouse. The UDF calculates the business logic and returns the $15 cost back to the agent to formulate its final answer. Let's discuss state management. Large language models are completely stateless. They have no memory of what you asked them 5 minutes ago. In the past, developers had to manually save the entire chat history in a database and send a massive array of past messages with every new API request. Cortex agents solve this elegantly using threads. Using the Snowflake REST API, you simply create a thread and receive a unique thread ID. For every subsequent message, you pass the thread ID and the ID of the previous message, known as the parent message ID. Snowflake securely manages the state and conversation history on the backend. This drastically simplifies your application code, reduces network payload sizes, and allows the agent to flawlessly handle multi-turn conversational follow-ups. This diagram visualizes how thread IDs link a conversation. Turn 1 generates a user message and an assistant message. For turn 2, the client application simply passes the previous assistant message ID as the parent message ID. Notice the dotted line at the bottom. Because this is a graph structure, you can actually fork a conversation by sending a new request that references an older parent ID, allowing users to explore different analytical paths without losing context. How do we govern the agent's behavior? Through the agent configuration object. First is model selection. While you can hard-code a model like Claude 3.5 Sonnet, setting it to auto allows Snowflake to dynamically upgrade your agent as newer, faster models are released. Next, you control behavior using instructions. System instructions define the persona, ensuring the agent acts like a professional financial advisor rather than a casual chatbot. Orchestration instructions are your guardrails. You can explicitly tell the planner, always use the analyst tool for revenue questions and never guess. Finally, to protect your Snowflake credits, you can define strict orchestration budgets. You can set limits on the maximum number of tokens consumed or maximum execution time in seconds, ensuring a confused agent doesn't loop infinitely. This class diagram breaks down the agent configuration payload. The core agent configuration object holds your model choice, instructions, budgets, and your array of registered tools. The instructions subobject is where the prompt engineering happens, allowing you to independently control the system persona, the logical orchestration rules, and the final response formatting style. Let's examine a highly practical real-world scenario. A retail manager asks an internal chatbot, "What was last month's revenue for our top winter coat, and what is the return policy for it?" In a legacy system, this breaks the app. But a Cortex agent handles this flawlessly. In step 1, the agent analyzes the prompt and splits it into 2 subtasks. In step 2, it routes the quantitative subtask to Cortex Analyst, which generates a SQL query against your sales database and finds the revenue was $450,000. In step 3, it routes the qualitative subtask to Cortex Search, which scans your internal PDF documents and finds the 30-day return policy. Finally, in step 4, the agent synthesizes these 2 entirely different data structures into a single, beautifully formatted natural language response. You have built a truly intelligent enterprise assistant. This sequence diagram maps the multi-tool orchestration. The user sends a dual intent query. The agent intercepts it and fires off a request to Cortex Analyst to fetch the SQL-based revenue. Once the $450,000 result returns, it fires a parallel request to Cortex Search to fetch the vector-based policy. Once both backend tasks succeed, the agent merges the context and delivers the final answer to the user. As we deploy to production, we must prioritize AI observability. Cortex agents emit detailed tracing logs during execution. You can view exactly how the agent planned its tasks and why it selected a specific tool, which is invaluable for debugging hallucination issues. Furthermore, Snowflake provides a native feedback API. You should wire this into your application's UI to capture user thumbs up or thumbs down metrics, allowing you to continuously iterate on your agent's instructions. Administratively, ensure your service accounts are granted the Snowflake.Cortex user role. Lastly, as a best practice, always configure reusable agent objects in Snowflake rather than passing inline configurations via the API. This enables proper version control and CI/CD pipelines. Thank you for joining this masterclass on autonomous workflows. I invite you to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final diagram illustrates the continuous improvement lifecycle. As the agent execution occurs, it outputs trace logs that fuel admin debugging. Simultaneously, the User Feedback API collects qualitative thumbs up and down metrics from your end users. By analyzing both the technical traces and the user satisfaction scores, your engineering team can drive continuous improvement of the agent's prompts and tools. Head over to quicktechie.com to accelerate your AI journey.